Welcome to another episode of Tech Tidbits, where we dive into the latest innovations in the tech world. I'm your host, and today we're exploring a fascinating new tool known as Wild, a linker designed to speed up iterative development, especially for Rust developers. So, let's unpack what makes Wild interesting. First off, what's a linker? Well, think of it as the traffic controller of your code. When you write a program, you might have different pieces of code from various sources that need to come together smoothly. That's where linkers come into play. They ensure everything links up correctly before you can run your program. Now, as many of you know, traditional linkers like GNU-LD and LLD are effective, but can lag during development, especially if you're frequently making changes. Enter Wild. The goal here is to provide fast linking times, which is especially crucial during the development phase. While Wild isn't incremental just yet, it's already showing promising speeds without that feature. So why would you consider Wild over others? Well, for starters, it supports development on x86-64 Linux, which is the common ground for many developers. If you're looking to speed up your warm build times, that's when you make small changes and need quick feedback. Wild might just be your best bet right now. Let's talk installation. It's pretty straightforward. You can grab a pre-built binary directly from their releases page, or, if you're feeling adventurous, you can build it from source using Cargo, Rust's package manager. Just a simple command, and you're set. Now, shifting gears to the question section. Why yet another linker when we already have fast options like Mold? This seems to be the common sentiment. Mold is indeed fast, but it doesn't support incremental linking. Wild, on the other hand, aims to achieve this in the future. The idea is to leverage Rust's strengths to help tackle the complexities of incremental linking down the line. Speaking of what's working, there's already a range of functions available, like outputting statically linked binaries and even supporting Rust proc macros. But it's important to note that it's a work in progress. Some larger features, like Mac support and a broader range of linker flags, are still on the to-do list. For our more tech-savvy listeners, if you ever want to check whether Wild has linked your binary, you can easily run some commands to find out. Just a quick tip using readelf, and you'll be in the know. And now here's a fun fact. The name Wild follows a bit of a tradition in programming land. Traditionally, linkers have names ending with LD, so adding an I for incremental sounds just right. It's a recursive acronym, fully in the spirit of open source projects. Before we wrap up, let's touch on performance. Preliminary benchmarks on linking a Rust application, such as the Rust compiler's shared object, have shown Wild taking around 486 milliseconds, which is quite impressive compared to its counterparts. However, it's worth noting that performance with debug info still has room for improvement. As we conclude this episode, remember that tools like Wild are all about enhancing our productivity and development speed. If you've ever found yourself frustrated with slow build times, keeping an eye on this project's growth could be beneficial. So, what are your thoughts on the evolution of linkers like Wild? Could its growth redefine development standards in Rust? Join us next time as we delve into more tech innovations. Thanks for tuning in to Tech Tidbits, where we celebrate the tools changing our digital landscape. Until next time, keep coding and stay curious.